Hello, ladies and gentlemen. Welcome back. We're just going to be going over the digestive system today, and specifically the pathway that the food is going to travel through in your body. Just as a little introduction here, we just need to think about what we've done so far and how it connects to the digestive system. So the big question that we like to ask at the beginning is, why do we eat? And we always get these great questions like, otherwise we'll die. But we're going to go in a little bit more depth than that. So the reason why we eat is all of the food contains specific molecules that we need for our body. And these molecules are going to look like this. So here they are. So these are our kind of four big macromolecules that we deal with in this course. And they're carbohydrates, protein, nucleic acid, and lipids. And you probably recognize most of those words. And we have specifically talked about protein and nucleic acid in quite a lot of detail in the DNA unit. But the main reason why we take these in is we need to break them down in our digestive system into usable products. And so the usable product for starch is going to be glucose. The usable product for protein is going to be amino acids. For nucleic acid, it's going to be our individual nucleotides. And then for the lipids, it's going to be a molecule called glycerol, and another one's which is a fatty acid. So those are what we're trying to get, and the reason why, if you look at glucose, we need it as our energy source. An amino acid is a building block, so when we have the building blocks, we can turn it into any protein we want to during protein synthesis. Nucleotides is so we can make more DNA when our cells need to be repaired or for growth. And then glycerol and fatty acid is going to be a way for us to store energy long term. So this is, again, why we eat, so we can get those smaller molecules for our functions in our body. So what we're going to be looking, like I said, is our pathway. What are the parts of the digestive system? And here they are. So it's going to come in through your mouth, go down your esophagus, into your stomach, into the small intestine, and then any of the food that isn't absorbed there will go through your large intestine and ultimately store in your rectum and out the anus. Now, each of these parts, there's quite a few misconceptions, and we're going to deal with them as we go along here. So first of all, as we mentioned, the main idea is to be able to get those carbohydrates, proteins, lipids, and nucleic acids into our body, to break them down. And when we break them down into those smaller molecules we saw, like glucose, then it gets absorbed into our circulatory system, which then takes it to all of the different cells in the body. Another couple things that we would like to get from our food are vitamins and minerals. And those are going to be used in our body in a concept that we've seen a little bit, and it's about enzyme action. They help to make your enzymes work more efficiently, but we will talk about those later. Now, let's start with the pathway, specifically the mouth. As you guys know, you have teeth. The teeth are going to be used to break down the food into smaller pieces. Not only does it help it get down the esophagus more easily, but it also increases the surface area. When you have small molecules, there's more spots on the outside of the food where we can actually use chemical digestion. So the first one is called salivary amylase. It's an enzyme that's going to help break down starch. So what we say in our mouth is that's where carbohydrate digestion starts. So as you guys might quickly remember, we had carbohydrates, proteins, lipids, and also nucleic acid. For our uses, carbohydrates is the only one we're going to focus on in the mouth, and the rest will start shortly. After we swallow, the food is going to be pushed down our esophagus. So here it comes in. Our tongue's going to push our bolus, which is the recently digested material, down to the back of our throat, and it's going to proceed down our esophagus. Now, the interesting thing about this is it's not like it's a tube that's just going to allow gravity to fall down. It's actually muscles that are involuntarily squeezing that food as it goes down the esophagus. So again, it's not due to gravity. That's why don't do this, but if you're doing a handstand, you can still eat, and it's going to go up because the muscles will squeeze. Okay, so that process is called peristalsis, and it's going to squeeze it through our esophagus into the stomach, and we have a sphincter there that it's going to be able to open to release that food. The next one is the stomach, and I'd say this is probably the biggest misconception organ in our digestive system. People think that the stomach is where all of your food gets broken down, when in fact it's only a small proportion of your food that actually gets broken down there. So as you can see here, we have an inner lining, and this inner lining is going to be protected by mucus. And it's so that hydrochloric acid that's in there that has quite a low pH won't start degrading the protein that surrounds your stomach. We have our gastric cells that will release enzymes, which we'll talk about in the next video, and hydrochloric acid. All that hydrochloric acid does is it starts to unravel those coiled up proteins, and it gives a specific pH environment for the enzymes to work effectively. As we've talked about, an enzyme activity, it depends on the pH. Now, as that protein starts to get broken down, it's then going to pass through another sphincter, which is called the pyloric, and this is what separates the stomach from the small intestine. So once we enter the small intestine, this is where all the heavy lifting occurs. So carbohydrates just started being broken down in the mouth. Proteins just started being broken down in the stomach, but there hasn't been any lipid digestion. So all the lipid digestion and all the rest of the carb and protein digestion happens in the small intestine. Once they're in their smallest building blocks, like we've seen before, the glucose, the amino acids, and the glycerol and fatty acids and nucleotides, they get absorbed out of the small intestine into these little small projections called villi, and they're absorbed into our body. And specifically, glucose and amino acids and the nucleotides get absorbed into our blood, and then but the glycerol and fatty acid don't go into our circulatory system, they go into our lymphatic system. So this little projection, which we call the villi, we actually have lacteals in here as well, and that is going to take you into a different circulatory system called the lymphatic system. Okay. Notice that these little projections are very long and skinny, and what that does is in the amount of space that you see here, there's a lot of surface area, and it maximizes the amount of absorption, which is the goal of the small intestine. So anything that isn't absorbed into your small intestine will just continue into our large intestine, also known as the colon. This is where essentially all of your absorption of your nutrients has taken place. The real goal of your colon is going to be the absorption of water. So the water that's in your large intestine, a lot of it's going to be absorbed into your body. It also is a spot where E. coli, so the bacteria that's in your gut, is going to be used to break down some of that undigestible material, and it releases a molecule called vitamin K, which will be used to help to produce proteins used in blood clotting. And then finally, as it makes its way through the large intestine, it's going to gather in the rectum, which will be used for storage. And then we have an anal sphincter that's going to prevent that feces from coming out until you're ready, and it will leave the anus into its end destination. Now, there can be a couple of issues, specifically water issues, that can occur in the large intestine. One of them is constipation. Another molecule that we have, or another substance we have, is called fiber. So these, a lot of the times, are undigestible materials, something like cellulose, that attaches to water, and it will keep that water in the large intestine. It doesn't allow all of it to be brought back into our body. However, if you do not have food with fiber in it and you're low in fiber, that water then does get absorbed into your body, which is great. However, you have a lack of water in your digestive system, specifically your large intestine, and now that feces won't be able to progress down the large intestine at a regular rate, and it gets backed up, which can lead to very large amounts of pain. On the opposite of that is diarrhea. And diarrhea is caused because when your large intestine is contracting through peristalsis, if it starts rapidly contracting, that's a bit of an issue, because that conveyor belt, which is your large intestine, starts to push the feces and the water out too quickly. As a result, that water is not absorbed back into your body, and that leads to diarrhea. Now, that's the main reason why diarrhea occurs. What you got to think about now is what are some of the things that can cause that rapid contraction, and it'd be things like illness, a bacterial or viral infection can cause it, food intolerance like spicy food or gluten, or also stress, which is not ideal. You're very stressed out for some reason, your body says, hey, you know what's going to help? diarrhea. So again, not helpful. So that's it for us. We are going to be talking about in our next lesson the enzymes that are involved in the digestive process. But this would be just the introduction, just knowing the pathway. Have a good day.